Good morning students, welcome you all for online classes. Today we will start the module number 3. Module number 3 has these concepts. One is random number generation and providing a freshness, fundamentals of entity authentication, passwords and dynamic password schemes, and zero knowledge mechanisms and protocols, and how to analyze a simple protocol authentication, and how we can going to establish key protocols. Okay, so what do you mean by entity authentication? An entity can be a person or a process or client or a server. These we can call entity. And what about authentication? It refers to an electronic process that allows for the electronic identification of natural or legal person. That's what we can call authentication. For example, if you want to log in to your Gmail account, so you provide the username, right, and password. These username and password will going to validate in Gmail server. Okay, in Gmail server, these server is act as what? Authentication. If both username and password match with server database, then it is nothing but what? Authentication. You can log into your Gmail account. Okay, and entity means here a person. You are a person, so you are entering your username and password. Those credentials will match with the server database, then we can call it is an entity authentication. Okay, now entity authentication is one of the security service. Basically we can call it is a security service, and many cryptographic entity authentication mechanisms rely on randomly generated numbers. So how these cryptography entity authentication rely on randomly generated numbers? For example, I want to generate a random number from 1 to 100. So 30. Okay, this 30 will act as a token between you and server. If I want to generate another number, 35 will going to generate. Each time it will going to generate different numbers. So based on these random numbers, you can assure cryptographic entity security. Okay, and random, how to generate a random number? Okay, these cryptographic primitives cannot function securely without randomness, because randomness is mandatory to provide a strong security with your data and between data and hacker. The need for randomness. Most cryptographic primitives, here primitives we can call symmetric key and public key and digital signature. I think you know very well about these terms, right? What do you mean by symmetric key and public key and digital signatures? These we can call primitives. And take structured input, turn it into something that has no structure. So these are accepting the proper input. Okay, for example, I want to input ABC. Okay, and After applying these symmetry key or public or digital signature, you will get something like this symbol, right? Dollar, parenthesis, and D, E, like that. So these we can call what? No structure, and these we can call proper structure. And many cryptographic primitives require source of randomness in order to make the function. Okay. So random number generation. For example, I want to generate a random number generation with these proper structured string. Okay, this is what AITM CSE 7SEM. For this input string, I can generate a random number. So this is a kind of random number with the help of RC4 encryption. Okay, if you decrypt this random number, then you will get your proper AITM CSE 7SEM string. Okay, this is how we can generate a random number. Then what is randomness? Randomness is about ideas such as unpredictability and uncertainty. This process is often assessed by applying a series of statistical tests. Statistical test means, suppose here I am giving values. Okay, these are our values. If I want to calculate the random numbers, then it will display number of runs, that is R and then P value. So this we can call statistical tests. Now, non-deterministic generators. There are two general approaches to generating randomness. Non-deterministic generator is based on the randomness produced by physical phenomena, and it provides a source of true randomness in the sense that source is very hard to control and replicate. Replicate means duplicate. So it is while duplicating, it is very difficult. For example, the number starts from 1, 2, 3, 4, 5, 6 and 7, 8, 9. Okay, 3 persons, assume 3 persons, they are producing their numbers, okay, in different ways. But another person, he cannot imagine that 1, 2, 3, 4, 5, 6 and 7, 8, 9. So that's why we can call replicate. And the true randomness is very hard to control and replicate. Means what? Another person cannot judge what kind of number he is using. Okay. For example, I take your online transfer. Okay, if you paying money to another person using website, take a website, and they will asking. Non-deterministic generators can be based on hardware or software. So let's see hardware based non-deterministic generators. They rely on the randomness of physical phenomena. The generators of this type requires specialist hardware. Examples: measurement of the time intervals involved in radioactive decay of nuclear atom. So this is what radioactive atom. So here we have to measure the time intervals. Okay, so it is somehow time intervals will appear on the particular device, right? That device we can call physical phenomena. With the help of that device we can observe the time intervals. Okay, this is what can say measurement of time intervals involved in the radioactive decay of nuclear atom. Another example, semiconductor thermal noise, which is generated by thermal motion of electrons. So this is also based on what? Physical phenomena. So hardware device. Instability measurements of pre-running oscillators and white noise emitted by electrical appliances. Measurements of pre-running oscillators means it requires some special hardware device. Okay, with the help of that hardware device we can measure the oscillators and white noise emitted by electrical appliances. This is a white noise emitted by electrical appliances. To produce these, the special hardware requirements are necessary. These all are based on what? Random numbers. And quantum measurements of single photons reflected into a mirror. So these measurements of single photons reflected into mirror, it is based on what? Random number. And hardware based generators provide a continuous supply of randomly generated output for as long as the power required to run the generator lasts or until the process ceases to produce the output. Because a specialist hardware is required, these types of generator are relatively expensive. Here what you have to understand that to generate the randomness you need random numbers, right? Those random numbers logic you have to apply in special hardwares. Usually these hardwares are relatively expensive. And now the software based non-deterministic generators. These rely on the randomness of physical phenomena detectable by the hardware contained in a computing device. Examples include capture of keystroke timing and outputs of system clock. Keystroke timing means if you press a key from your keyboard, okay, that randomness, you are typing randomly, right? So that key pressing and key releasing, it will notify the time. And output from system clock. This system clock will generate number, right? So that's what we can call, it's a system clocks time. So these are based on what? Software. Here how the software will generate a randomness, okay, with the help of hardware device. Hardware device is necessary. And hard drive seek time. So this is what your hard disk. Okay, here what will happen? Whenever your disk is rotating, this is what rotator head, it has the seek time. in particular rotation, what is the time, okay, while reading or writing your data. So this is how based on random numbers and capturing a times between interrupts, that is mouse click. When you press the mouse, so it is based on randomness, and if you are moving the mouse, right, and computations based on network statistics. So in take the example of this network statistics, here you need randomness. These all are software based examples, and the disadvantages of these deterministic generators are they tend to be expensive to implement. Like that, I have shown the animations. To produce that kind of environment, it requires what? Expensive to implement, and it is essentially impossible to produce two identical strings of a true randomness in two different places. Okay, it means they will keep on producing different random numbers. So this is a disadvantages of non-deterministic generators. And what about deterministic generators? We must be give us some input as a string point, and this input determines the sequence of numbers generated and is known as the seed value. Okay, here if you give input from one number, and it will keep on produce the random numbers. For example, see here, here it is asking, there are 4 types of algorithms to generate a random numbers. Here I am going to choose x to the power 2 mod n random number generator. This is my seed value. Based on this seed value, I can generate, okay, and the length of this is 512 byte. This is what length of the random numbers, and these all are random numbers generated with the help of seed value. Okay, with the help of these random numbers, we can communicate with two persons in secure manner. Okay, for example, this number, take this number. If this number is generated, okay, and if you match your authentication to another person, that same person also type this number, then only authentication will correct. Otherwise, and this big number, another hacker cannot guess this is a number. Okay, this is what we can say random numbers. This model of deterministic generator is an algorithm that outputs pseudo-random bit string, and the output of deterministic generator is certainly not randomly generated. If anyone who knows the information that is input to the deterministic generator can completely predict the output. If input into deterministic generator is secret, then with careful design of generation process, generated output will have no apparent structure. For example, this seed value we can make secret. Based on this seed, they will going to generate numbers, right? It will thus appear to have been randomly generated to anyone who does not know the secret input. If other person knows this input, so see, he can easily generate a random numbers. So better we have to secure this our seed value. This is precisely the idea behind deterministic generators. And seed, the secret in what do you mean by seed here? Seed is nothing but a secret information that is input into the this is what seed value. Okay, deterministic generator is often referred to as seed, and this is essentially cryptographic key. Of course, it is a key, and the seed is only piece of information that is definitely not known to the attacker. If attacker knows this seed value, he can easily generate random numbers. Here seed value is what? 1073. Give another number, that is 100. Okay, then generating numbers. Okay, based on this seed value, it will going to generate. To preserve the unpredictability of the pseudo-random output sequence, it is important both to protect this seed and to change it frequently. And what about generator? It is a cryptographic algorithm that produces the pseudo-random output from the seed. See, these are our algorithms. Secured library random number generator, x raised to 2 random number generator, linear congruence generator, and inverse congruence generator. These are types of generators. And in practice, they are cheap to implement and fast to run. It is no coincidence that deterministic generators share their advantages with stream ciphers, since the key stream generator for stream cipher is deterministic generator, and two identical pseudo-random outputs can be produced in different locations. All that is needed is the same deterministic generator and the same seed value. If one person will going to generate a seed value, assume 110, and another person, means different locations, right? So in another person, he also need the same secret key or seed value. So generators will same. And properties of non-deterministic and deterministic generators. In non-deterministic, close to truly randomly generated output, here pseudo-random output, and randomness from physical source, here randomness from seed, random seed, and random source hard to replicate, here easy to replicate. Replicate means duplicate. Security depends on protection of source. Here security depends on protection of seed value. Relatively expensive, and this is relatively cheap. Deterministic generators. Okay, if you have any doubts regarding these concepts, please ask me. Thank you.